All right. Welcome back to another episode of the It Depends podcast. Today, I have the distinct pleasure of inviting Shireesh Thota back on my podcast. This is the second time we are doing this. The last time was very interesting because, if I may, he was on a hiatus from Microsoft. And when we met and we talked all things databases, it was when he was running products at Single Store or MemSQL as it was called way back. So now he's back at Microsoft. I will let him do his own introduction, but so much has changed in 3 years that it feels like we have a whole new ocean of topics to cover. So we have a lot of ground we will cover today. But before we do that, Shireesh, so great, so glad to have you back. Welcome to the podcast.
Sanjeev, thank you so very much. I'm excited. I'm honored that I have the second chance to be here. So I truly am thrilled to be here. As you said, yes, it was in a different context and it's different times. A lot has changed. I am back at Microsoft. I really look forward to talking to you, covering a lot of ground today. Yeah, I'm thrilled to be here. Thank you.
Very nice. So we'll get started. So I'm going to ask you some questions that are more conceptual. Then we'll go look at what Microsoft is doing, and then we'll end there. So, so you were at Microsoft, and now you're back. What was the catalyst, and what is your remit? What do you cover at Microsoft?
Yeah, so as a lot of my friends here say that I can be taken out of Microsoft, but Microsoft can't be taken out of me, I guess.
Understood.
uh, I did enjoy being at Single Store. It was a fantastic experience, great leadership, great people, great tech. It's very novel. It's super cutting edge. Um, but this opportunity that I got here at Microsoft to lead all operational databases,
Hmm.
uh, just too precious. And I cherish this opportunity, and I really am humble and grateful that I get to do this. So I came back to Microsoft after a really awesome time at Singapore. My remit, to your point, includes all of OLTP databases. So I work on all operational databases at Microsoft. So this includes SQL Server on premises as well as Azure SQL, the entire SQL family, and then Azure Cosmos DB, a non-relational database. And then there are OSS databases, so both Postgres as well as MySQL. And so I think about everything that's OLTP, and it gets shipped in various form factors. We have support for on-premises with SQL Server. We have hybrid support. We have Azure PaaS offerings, as well as databases coming into Fabric, which I'm sure we're going to dive into it a little bit. But anything about OLTP being offered everywhere at Microsoft, that is my remit.
We had a very interesting observation in my previous life when we used to build these end-to-end data architectures. We would have OLTP databases, then we would have all kinds of data integration, data transformation pipelines into analytical, then we would have BI, we would have AI, and we realized one day that OLTP is just a tiny sliver, and then we're spending 90% of our time on the rest of this pipeline. So I always felt that OLTP databases are sort of the bread and butter of an organization, but they get the short shift. I wonder, is that true now? Also, changing on similar vein, we saw Snowflake bought Crunchy Data, Databricks bought Neon. So these analytical powerhouses are buying OLTP databases as well. What is your perspective on where OLTP database is today? Why are these database companies interested in the transactional operational side of things?
So firstly, I do acknowledge that, data space is obviously much bigger than OLTP. I
Yeah,
don't want to claim
correct.
that in any other way. So I do agree with that. One thing that never changes, and this is the reason why operational databases, OLTP
Mhm.
databases, look at the TAM, it crossed $100 billion and it continues to grow, right? It has a very exciting growth rate. It's simple. It definitely is extremely crucial for any application, right? Obviously any meaningful application wouldn't succeed without OLTP, and and then when you combine it with the fact that you have to really go do the system of record stuff and how important it is in terms
Mhm.
of general ACID characteristics and security aspects, etc., you really are not going to get away anywhere. You can't even get started with a data project without OLTP. So, it has its very important, extremely crucial role to play, but it is not the entirety of the data space. And then in the recent times, to your point, I think it is fast becoming again strategic high ground for organizations that are trying to build AI and agentic systems and the entirety of the sort of the modern data platform stacks. So I think what looks like a sudden OLTP hiring spree in the market is effectively a validation of the vision that we at Microsoft have, which is to basically really unify the entirety of the data estate. And this is what we are doing with Microsoft Fabric. And there are lots of reasons, but the primary thing is that once the data is born somewhere, typically in an operational database, you want to get the insights of this data really fast in a very seamless fashion. Uh, and the thing that is really driving the acceleration is that agentic AI related Gen AI apps, etc., they're collapsing the walls between these transactions and analytics because it needs to be like a closed loop. It needs to be really fast if you want to get lots of insights from AI. So you have to really win both sides on both sides of transactions analytics. You want to be very latency sensitive. You got to provide great governance and consistency of data, not have multiple copies without knowing what is the lineage of data and having to deal with too many services, too many integration points. And Microsoft got there already with Fabric. And with databases coming in, which is just the recent news, we have customers already running the mirroring, which is the zero ETL aspects of it, translytical uh, friendly workloads, AI friendly workloads at scale, and these are the reasons why I think you would see the market sort of coalescing around unified data platforms, and it's just a validation of this data fabric.
For
Stack.
sure. Yep, we talk a lot about Microsoft Fabric
Yeah.
as we go on. One thing that I found very interesting you said was that OLTP market crossed 100 billion in TAM. How big is analytical market?
I don't have the exact number. I'm
Is it
assuming
bigger or is it growing faster?
I think it's growing faster
Okay.
naturally because LTP has been there for quite a while and it
Yeah.
definitely enjoys the sort of the history. But I think analytical market, if I remember it right, I think is growing faster. And this is an IDC estimate, and this is not my estimates. Yeah,
Right.
yeah.
So talking about OLTP databases, it's interesting how when I started my career, I my first job was at Oracle. It was all relation databases. Luckily, I avoided the pre-relational IBM mainframe databases, but it was almost all RDBMS. And then NoSQL non-relation databases came out, and there's so many different types of it. And then when you were at Single Store, that's kind of an HTAP. You talked about Microsoft Fabric having operation databases with zero ETL, the mirroring thing. So I'm curious, where do you see a database that's multimodal with all kinds of like graph and document, relational, spatial, or do you see there's value in having purpose-built databases?
It's a great question, and I think the pendulum keeps swinging between the purpose-built engine and sort of like one size fits all on one side, and then the right tool for the right job in the other side. And then we kind of think of it as two extremes, and I've come to appreciate that you have place for both, and it's a spectrum. It's definitely a spectrum.
Hmm.
Um, there are lots of different things. If you think about the purpose-built OLTP engines, they win on latency, global consistency, strong consistency, ACID characteristics, etc. Right? And then on the other hand, if you think about these HTAP kind of workloads, non-relational workloads, etc., they all have their space in that continuum. And there's like on the far end, if you think about relational and non-relational, non-relational was born because we wanted to do scale, global sort of replication, and you want to make sure that high availability is guaranteed, including active and all that stuff. And now there is this motion of building the distributed SQL, trying to get the best of both worlds, right? That is one sort of like spectrum. There's the other spectrum of trans-analytical HTAP, OLTP, OLAP, etc., trying to really converge as much as we can. There's definitely a new momentum on trying to do quite a lot of things in terms of Iceberg with Postgres, for example. This is a new thing that's just popping up quite a bit. And then AI databases coming together, etc. So my view is that I think you have to have specialized services.
Mm.
Like in our case, we have SQL for relational, Postgres, MySQL as well, open source workloads, etc., and Cosmos for non-relational. But it is about bringing all these pieces together. So you got to have specialized purpose-built tools on the edges, so that if you need any workload that really needs the depth of that
Yeah.
characteristic, you got.
Mhm.
But the magic is when you tie all these pieces together, when the seamless migration movement of the data across these different pieces happens,
Mm.
instead of saying I'm going to build everything in one engine and really magically get all the pieces together, because it's impossible. You really are not going to have everything in one engine and try and do that. So HTAP, I think, as a strategy, as a customer offering, makes a ton of sense. But I feel like I've learned enough to appreciate the need for specialization on the edges, but generalization and really seamless integration. And this is again going back to sort of fabric kind of an architecture where you're really making it super easy. But there is a place for streaming. There's a place for distributed SQL. There's a place for AI databases, and all these pieces are extremely important.
Since you
Yeah.
mentioned AI databases, what is in your view, the future of these vector-only databases like Milvus, Pinecone, VV8, all of
Yeah.
these?
Yeah, I mean, I appreciate the tech, and I appreciate all the efforts that are happening in the industry. Our view is that we would basically have vectors as specialized indexes as part of the operational databases. Operational databases have had a very rich history of accommodating and absorbing all kinds of indexes in the past, right? It started out as just regular B tree for your structured
Yeah.
data, but over the course of time, we've added XML indexing, we've added spatial indexing, we've added full text indexing, all of them in the vanilla
Yeah.
operational databases. SQL Server did it, Oracle did it. Um, and we think vector indexing, although it is very compute intensive, although it is a special, it's a different form of a high
Mhm.
dimensional graph index, it's not trivial. But on the other hand, I do think that keeping all the data closer to the operational databases bring a significant amount of advantages to the customer in terms of consistency of the data, you close loop of AI actions. RAG is a real pattern, and you want these kinds of things to be happening closer to your system of record or system of engagement or user facing, in whichever form you think about it. Indexes being closer to operational databases is a very important scenario. I also want to acknowledge that there are search scenarios where you want to have a specialized like indexing on top of your broader data lake definition, and this is where we have in Microsoft, we also have AI search, which kind of does that stuff. So it's our view as operational databases, as sort of like what I do for my day to day on OLTP. I think of vector indexing as really crucial part and parcel of the operational database.
So vector is literally a data type. So
Yeah,
vector
correct.
index can live. So vector data type and index can live anywhere, right? Any could be.
Just yeah, when you see a vector type, it's typically a float of
Right.
hundreds of. It's a vector of
Dimension.
hundreds of floats, right? So
Yeah.
it could be thousands, and what we need to do is to store them, serialize them in the data type, and operate them in the
Mm.
runtime query, etc., etc. Uh, Relational databases are good at it, even though it is a high dimensional stuff. It could be a couple of kilobytes. We can manage that. The
Mm.
challenge becomes how do you index it, especially for ANN indexing. And there are definite technologies. If you think about what Postgres did, PG Vector is the popular extension. They have an algorithm called HNSW. It's a data structure. It's a graph index basically, but it's very memory heavy. What we have done at Microsoft is something called DiskANN, which is, and I can talk on about that quite a bit, but it is basically it's a flexible memory architecture. You could keep as much as you want in the memory so that you can trade off for speed. But whenever you need to spill it over disk, we support that as well. But this index is complex. It's not unlike the simple like the usual index.
B3. Yeah.
Yeah, it's not as simple as a B tree is. It is multi dimension. You got 1,500 dimensions, for instance, in GPT-4 or whatever kind of embeddings.
Mm.
It's a high dimensional. It's graph index. So you think of it as like spatial KD tree, but multiplied even much more. So it is indexing here is not trivial for sure.
Got it.
Yeah,
Okay. So, and just to parse a few things you said for those who are listening, ANN is approximate nearest neighbor, which
correct.
is how you index in this space with multiple high dimensional embeddings. And then HNSW is the original indexing from Meta, Facebook. And so you've now created disk ANN, which
Correct.
is
Yeah.
the optimized
Yeah.
version.
Yes,
Got
there are
it.
a few versions, IVF flat, HNSW, that have been popular,
Right.
and we have created DiskANN, and this came from Microsoft Research, and we've incorporated into all our operational databases.
Right. So before we proceed, you also mentioned distributed databases. And remember, many years ago, Microsoft bought a company called Citus.
Yes.
And then just last year, December, AWS reInvent, we heard about Aurora DSQL. What is the growth of distributed SQL databases? And and what's Microsoft's vision about it?
Yeah, great question, Sanjeev. So, naturally, the way relational databases have evolved, or databases all up have evolved, were that they're all single instance, single node
Yeah.
instance, right? And it's very hard to basically think about doing concurrency control across
Mm,
multiple nodes. And it's very hard to do ACID properly across, right?
mm,
And we've invented quite a lot of different algorithms to go do that. Um, but the scale at which you want to operate and the way the relational databases have initially been designed, now there's lots of changes. There is a mismatch. There's an impedance mismatch there. So, we went to a scale out form factor, and this is kind of really what the non-relational is. That's where the distributed era has begun, right?
correct. Yeah.
Mm. And it gives you great amount of scale, but at a trade-off. Typically,
Yeah.
you don't functionally rich query, you don't get great ACID characteristics, etc. But the industry has been working really hard, and I'm excited to be in this space at this time that we are innovating quite a bit. There's lots of people who are innovating in this space, trying to marry these two aspects of having the relational aspects, but also basically making sure that the scale out things are great. Commodity servers gave us scale out, and we basically took that and put it for superior elasticity within a region, as well as global replication. So you could do global replication for active active or active passive. There's one writer and multiple readers, or everybody is writing, and then you figure out somehow some kind of conflict resolution mechanisms, etc. And that all was like fine. And there's lots of workloads which really thrive on that kind of an architecture.
Mhm.
We have in our house some Azure Cosmos DB, which is a non-relational database that is specifically designed for a NoSQL kind of workload that can do superior elasticity, high availability, even active, 5 nines, single digit milliseconds globally. So amazing characteristics. Now, the newer wave, as you were saying, is about the distributed SQL, which is sort of like combining the relational aspects with that of the non-relational characteristics. And there is definitely a huge place for this. A lot of competitors have started doing it, and we also have our own take on this. If you look at what we have done with Citus, and Citus kind of really evolved into Elastic clusters as a feature in our Postgres offering. Um, it can basically help you shard the data at a database level, at a schema level, or even at a row level. So you could basically do multiple different kinds of sharding. That sharding effectively scale out. It gives you the ability to really go keep the relational characteristics, but keep on adding without having to worry about limit your storage or compute and whatnot. We also have something called SQL Hyperscale in our Azure SQL family that disaggregates the compute and storage, and storage can scale independently of compute. You can have as many replicas. It's practically many replicas as you can have, that can scale, and then the storage can scale independently. The architecture really works. So I'm excited, and we
Yeah.
have a very thriving
Mm.
sort of like piece of work here where we are doing distributed SQL in our own world. and we are investing quite a bit in this space.
Yeah, we are going to go to Cosmos. We have one more question about agentic AI. But before we even do that, I just want to clarify that with Citus, you can shard the data across different nodes, so you can have multiple writers. But the data is distributed. It's not like in a distributed SQL, you would have multiple writes on the data in the same location, like geographic location, and you would have some consensus protocol. You don't have that, right? That's not what we're talking about.
So with Citus, you basically think of it as like any node. You can basically call it as like create table, but in a distributed mode, and that
Yeah,
table gets sharded into a number of things. You can come up with like your sharding approach. Let's say you sharded through a key or something like that, and it can define this is the partition. It's in this row, in this
yeah,
table. In this node, it defines it into different kinds of nodes, and then you have basically 2PC, which can help you do distributed
yeah,
transaction. We
yeah.
support
Two
that as
phase
well.
commit. Yeah.
Yeah, two-phase
Okay.
commit that can help
I'm
you to.
translating it for people who.
Yeah, right. Yes, and it helps you basically go do your sort of scale out as much as you need to.
Yeah,
There is an evolution of the same architecture um, in slightly different ways. These are all like it's really not a two-dimensional. It's kind of like a spider chart in terms
right.
of what you want
Yeah,
to think about. There's a scale, there is volume of data. How can it do split and merge? Can it do global replication? Can it do isolation consistency guarantees? So
mhm,
different kinds of DSQLs have different kinds of characteristics. There's no one definition, uh,
right,
right? So some people do multi-partition snapshot isolation. Some people claim that we can do strict serialized, but these are different levels of consistency levels,
right.
right?
Yeah,
As data grows, as the scale increases, and it is not really one, two dimensions, it's multiple dimensions, and hence it's a spider chart more than just a simple quadrant. How to place these distributed
yeah.
SQL databases. Yeah.
Amazing. I have one more question, and before we go to Microsoft's offering of operation databases, and that has to do with agentic AI, and I'm truly confused with
Mm.
how did Postgres database morph from being an OLTP asset compliant transactional database into an agentic database, because when Databricks bought Neon, we learned that 80% of Neon instances are created and then shut down by agents, and the whole database is ephemeral, comes and goes. And I would love to hear your views on what is the role of a Postgres database like Neon or any other ones in the agentic AI space.
So, firstly, it kind of really speaks to the strength of Postgres code
Mm,
base and Postgres architectural challenge, architectural strengths, right? It speaks to the way that Postgres is available. It's flexible in terms of how people can innovate. And there are different vendors who have been innovating in this space, and we have our own take on this. But at the end of the day, there are a few common characteristics. And then there is innovation. Everybody has their own sauce. But the common characteristics that I would touch upon is that Postgres is flexible in terms of adding new types, new indexes. So
mm,
people have gone ahead and taken advantage of it. So we have this PG vector extension. We have announced DiskANN capability into Postgres. So this is like our very popular ANN indexing approximation nearest neighbor indexing to do semantic searches inside Postgres. So we have done our part, and there are different vendors who've been doing similar kind of things. But that is there. Vector type, vector indexing, that's
yeah,
check,
but so
right?
that takes care of Gen AI workloads, or
Correct.
like
Right.
RAG. But what
Yeah.
about like
That
agents?
takes care of RAG. And then you're talking about agentic apps. The some of the key things for agentic apps is that firstly, any app, any stateful app requires a database.
Yeah.
And some of the characteristics of agentic apps is that they need some amazing low latency and most importantly serverless kind of characteristics.
Mm,
And Postgres has been taken apart by and it's been taken apart and basically said that compute can scale differently from storage, and you could do different kinds of architectures where you could have storage in different form factors. One of the things that you could do with storage is basically that, and this is what Azure Hyperscale, SQL Hyperscale does. um, I know there are a few other instances of it, but once you do that storage compute disaggregation, separate them out, decouple them, you basically can really build a serverless form factor that is very, very uh, sort of custom built, purpose built for these closed AI agentic loops. Because, as you said, ephemeral storage and bringing some new storage form factors coming in. You want to just bring up a new database on the fly. Your agentic apps, there are tons of them. So you want the database to wake up when you need it, but go back to sleep. So there's that architectural strength that Postgres brings. Now, I know there are a few other databases. We've done this with SQL Hyperscale. We're doing it with Cosmos DB as well. But Postgres, given that open source community strength, etc., it's really designed for that kind of stuff. You could also bring in a lot of the LLM power within the engine because, again, it's easier to extend it. So if once you do that, agents can take advantage of delegating some of the work to the database instead of trying to pull the data out into the compute layer and processing it. They could push a lot more into the Postgres engine and let the Postgres engine be, in fact, a part of the. It is an agent in the multi-agent orchestration kind of a framework, right? Instead of thinking of it as like a simple database, you think of it as one of the agents that I'm going to delegate it to you and you do your work. And then there is a compute multi-agent orchestration framework. In fact, I think we have a GitHub sample which does exactly this with our Postgres.
Yeah,
um, and that's all possible because of the extensibility and naturally the community's enthusiasm and the constant innovation is something to be definitely cherished.
that's great. I want to change tracks here and talk about the various databases that are in your remit, operation databases, and I'm curious to see what's new, what's changed, what are the strengths that you're playing with these databases. And so I want to start with SQL Server 2025, then we'll go
Yeah,
to Cosmos DB. I think SQL Server 2025 is the first release since 2022. Correct me if that's not the case. It's
you're
been
right.
a while,
You're right. I mean, we have a general cadence of 3 years,
3 years. I see.
around
Okay,
3 years. So we are hitting that number.
got it.
Uh,
Okay.
but yeah, you're right that SQL Server 2025 is the biggest sort of release that's going to come out. So you asked a question about the entire portfolio and really the important ones that are happening at Microsoft and in the sort of strengths. So firstly, we have a very rich portfolio, and it's one of those interesting things in the operational database space where you have more than one option, and they're all really good databases. And even though building a database takes a long time, we do have a few options. SQL is where we always begin. It's battle tested for several decades. It's sort of enterprise ready with a significant amount of mission criticality, security, performance, and all those usual things. We take benchmarking very seriously. Um, and we continue to do that with SQL 2025 with one major addition.
Hmm.
SQL 2025 is the first time we're bringing AI into our flagship relational database. So we are going to add native vector type, native vector indexing built into the engine. And it works very seamlessly. If you have, uh, imagine if you have something like an Olama server on premises in your gateway or whatever, you could just integrate with that and operate inside a store proc in SQL Server, just as on-premises kind of instances. So it really works natively. And we have something called Arc that basically gives a hybrid strength to this on-premises instances to work with Azure, including things like bursting from on-premises into the cloud. You can think of the cloud as a replica for a HA system where on-premises is one of the replicas, and it could burst in. It could do backups and restores into the cloud. It could use the Azure monitoring capabilities, security capabilities, even Entra, which is our sort of like our secure ID managed service, and you basic managed service identity, and that basically can be given even to on premises. So we're attaching a lot of Azure if somebody wants to attach, even though they want to keep their data locally. That sort of arc and
Uh,
hybrid.
Yeah.
That is where SQL Server begins, and that's the first part of my portfolio. And I'm sorry, you had a question.
Yeah, I had a question about every database vendors adding MCP server, which means I could be in my Cloud Code and I could just say, show me all the tables or give me this some weird query I can just ask in natural language. Is that coming in SQL Server 2025?
So all of our yes, it will be available in Azure SQL first, and then we are definitely
I see.
bringing to SQL as well. So any form factor, yeah, and it's already available for Azure PostgreSQL and Cosmos DB as well.
Hmm.
And there is another strategy. There's a broader strategy with Azure. We have an Azure MCP server where everything is registered into. So all these databases are registered into already. But yeah, SQL will be quite AI first, AI ready pretty soon, as soon as SQL 2025
So
comes
if
through.
you have Azure MCP server and you have MCP server and Cosmos DB, are these
Mhm.
two separate pieces
So
of
yeah,
code?
they're composing, but if somebody wants to directly go to our databases, we offer that as well. If
I
somebody
see.
has a tooling and they just want to directly go to our MCP, just let's say if they are a direct Postgres customer or direct Cosmos DB customer, they're in their favorite ID, and if they just want to use that
When,
alone, we
I
got
see.
it. Yeah.
When is Azure SQL coming out?
So SQL 2025, you mean? Azure
Yes,
SQL,
yeah,
yeah.
SQL 2025 and then the Azure SQL
Yeah,
version.
so MCP servers we keep, we're already in Azure,
Okay.
and SQL 2025, as the name suggests, we have to get it done this year.
Yes.
So yeah,
So
we're working on getting it done.
you have Ignite coming up in November. So
Yes, yes, Ignite is our big, yes, it's our flagship conference. Yes, so we're working towards getting SQL 2025 ready soon.
okay.
Um,
Okay.
Yeah, yes.
All right.
So to complete your question about the portfolio,
Yep.
we have a SQL Server, and then we have Azure SQL. Azure SQL is basically our managed offering, and there are lots of rich varieties of Azure SQL. And this is basically the best way to run your SQL in cloud. We've taken all the pieces. It's the same engine. It's sort of what people are used to. It's the most powerful engine relational database that we've been working for several decades. It's managed offerings, and there are different kinds of offerings. One of the things that I want to touch upon is Azure SQL Hyperscale, which is the disaggregated storage compute
Mhm.
architecture. You can have 15 read replicas, one write replica, but storage is disaggregated, so you can store as much as you want. We have many customers who go up to hundreds of terabytes, 100 plus terabytes of relational workload. So there is that. On the non-relational front, as I said, we have Cosmos DB, and there's
Right.
lots happening in Cosmos DB. I know you mentioned that we can go into it a little deeper, but at the forefront, I would just say that it has the elasticity, HA, and low latency guarantees on top of this flexible schema kind of a modeling capability. Um, and that's the reason why many of our customers, including many of our Microsoft's internal first-party services, continue to use Cosmos DB. So that's that. And then in Postgres and MySQL, these Postgres, of course, there's a lot of focus that we've been putting in Postgres. You may not know this, but amongst the hyperscalers, we actually are the number one in terms of the volume of commits made to Postgres source code. So we have a
Oh,
huge committer team
yeah.
that that are their focus is to make sure that the committer team is really focused
Mhm.
on making Postgres source code thrive and continue to succeed. We have a lot being worked in this space, and I can say in Postgres, please stay tuned. There's a lot that I cannot talk now, but
Okay.
there's a lot that we are investing,
Yes.
and we are excited about working with community and furthering Postgres all up. It's not
Yeah.
just for one vendor, but for all of us, for the entire industry. And MySQL is also a managed offering that we have that is really great for migrating your commodity community server editions of MySQL, and we're pushing there as well. And then all these databases come into Fabric too. I can hold on until you get
Yeah,
to.
let's get to that in just a second because just for the viewers who are listening to this and don't know about Cosmos DB, it's a key value and a document store, but it has all kinds of multi-model APIs. SQL is of course out of the box, but then it has MongoDB compatibility and Apache Cassandra, correct?
Right, that's right. And MongoDB is one of our popular APIs. Again, kudos to Mongo. They have made this API really popular, and it's a very well understood API across the developer community. So we respect that, and we are offering that API as well. And so we have a yeah, and as you may have noticed, we also have announced an open source project in this space called
Ah,
DocumentDB. Yeah.
DocumentDB, I see.
Yes. Yes.
And what is DocumentDB? What does it do?
Yeah, so what DocumentDB does is basically try to give, if you think about relational space, there's quite a lot of open source flexibility for the community. In the non-relational space, there's a bit of a gap here, right? There's not really as much of open source community work that's happening so that people can really be comfortable in terms of being, just having the same benefits as open source. So what we have done here is to introduce DocumentDB as a project, and we are looking for more partnerships and all that stuff. But the idea here is that you have Documents API compatible with Mongo.
Hmm.
Underneath, though, we have created two extensions for Postgres. So this is really a Postgres play, but it is wrapping Mongo API on top. We have an extension for Postgres that supports BSON indexing.
Hmm.
BSON is binary JSON. It's an advanced form of JSON. So you can basically have schema flexibility with that column, with BSON column inside Postgres. So we've contributed that extension to Postgres. So people who are looking for JSON-like, BSON-like capabilities in Postgres, they got that. And then the other extension is to basically support the Mongo API on top of a Postgres instance. Postgres being very flexible, it could be really morphed into different kinds of shapes. So we have taken advantage of that and contributed these extensions so that DocumentDB as an open source project can thrive. So we're slowly moving that into sort of making it as an open effort that's across all the vendors, across everyone. We will see how far we go, but we are really excited about
So
that project.
So I can either get full-fledged MongoDB or Atlas, the cloud version, or I can have MongoDB application point to Cosmos DB and store like with data in Cosmos DB. Or now I can use DocumentDB, which is relational Postgres, but it has compatibility with MongoDB API, so a MongoDB application can work on top of DocumentDB. Is that correct?
That's right. That's exactly right. Your understanding is absolutely right. And we are trying to collapse two and three because what we have basically done is
Hmm.
taken all our Cosmos DB implementation of Mongo API and trying to really go contribute a lot more to
I
Document
see.
DB. But these are the options. You captured it really well.
Okay, I'm all for like simplification,
Yes.
reducing the number of options. Like kids, you give them more choices, then you have no
Yes.
idea what will happen. So fewer choices. Choices are
Yes.
good, but not
Yes.
too many. So
Yeah. No, I mean, I think Postgres is really powerful in terms of
yeah,
enabling you to go
I
do the
like it.
things.
Yeah.
And then the other advantage is that you could actually do more that Postgres has in the form factor of this Documents API. Postgres is rich because people keep adding more extensions and it continues to thrive. So you could really bring all that goodness in the form of Documents
Mhm.
API. And then the community really can build uh,
Yeah.
whatever applications in whatever form factor they want. If they want, a lot of customers want JSON as first class
Mhm.
instead of going through relational schema. There are a lot of applications like that. Let them be. But underneath, though, the power could be same.
Yeah. Okay, got it. I know this is probably early days for DocumentDB, but do you have, can you talk about adoption outside of Microsoft?
Yeah, so there's quite a lot of interest in terms of partnerships. We've made a few partnerships, but we will be adding. I mean, again, we're working through. It's very early at this point to share like specific numbers,
Hmm.
but there's definitely a lot of interest in terms of open source developers, just the community looking into our extensions and reaching out to us and talking about the changes that they would like to do, etc. So that we will have a lot more to talk about it as we go along. But I'm thrilled looking at the amount of adoption. It's just the interest
Hmm.
that the developers have. We've got lots of sort of requests to make edits to contributions already, and we are working through that.
That's amazing. Going back to Cosmos DB and Microsoft Fabric. So now let's tackle that. What is
Yeah.
going on between these two? So Microsoft Fabric is your data fabric. It's a unified analytical offering, if I may.
Yeah, yeah. I think that's a very good explanation.
Okay. What's new with between the two databases?
So, firstly, Cosmos DB, just again briefly to remind the audience here that it is a non-relational database. It's highly
Mhm.
available, globally elastic, documents, APIs, key values, scale workloads, etc. Um, Fabric has set out in the early version, basically started as a unified analytics platform, right?
Mhm.
We brought together everything from Power BI, ADF, all the data warehouse pieces, etc., into sort of like really a pre-integrated SaaS environment where we have data integration, we have data science, data engineering, data warehouse, real-time intelligence, BI with Power BI, and now with operational databases, it has evolved from being an analytics platform to a unified data platform with a pre-integrated SaaS environment that's kind of custom built for specific personas. And yet it's really the right choice for the CDOs who are trying to get the entire estate. What we've realized is that if you want to really go win this kind of this journey of becoming super unified for the CDOs, you got to have operational databases in the realm as well, because that's kind of really the place where the data gets born often, right? Before it goes to this modern data stack. We've simplified the modern data stack, but we also needed the operational databases to come in. So with the operational databases coming in, it truly becomes a complete platform. So the first step in that direction was to bring in SQL into Fabric.
Hmm.
We've made that happen at Last Ignite. And now, just recently at Build, we basically a few weeks ago, we basically announced Cosmos DB coming into Fabric. And what happens when Cosmos comes into Fabric specifically is that, see, Cosmos is designed to be, it really has all the characteristics of being a great AI ready database, right? And we got the world's premium serverless, non relational database with vector support built in. And we have a lot of customers already using it. SQL is already there in Fabric, but now with Cosmos coming in, this emphasis of closed loop AI, that sort of shines through here. Given speed of Cosmos DB, we could use this as a serving layer for all of the analytical data that could be there in one lake, right? It's a really good serving layer. So you could be doing some kind of a reverse ETL or whatever you want to call it, and serve it really fast with Cosmos DB. It can auto index. It can really do quickly what you need for serving layer. The other thing, and this is just an example, if you look at the patterns that are there in the high performing application estates, one of the common patterns is databases plus messaging with real-time analytics, etc. So generally data gets out of the microservices architecture is that you have some kind of an event bus, Kafka, event hubs, etc. running through, and then you have these microservices which push and pull data from the bus into their databases, into their service, and then they change feed back into the bus. And it's a very common event-driven architecture. Those kinds of patterns become extremely simpler because all of the estate is integrated in Fabric. It's a common security model,
Hmm.
a common tenant model, so you can manage all these things really easily. It's a very simple and easy
So,
business.
so what I understand is this is what I learned at Microsoft Build. Correct me if my memory is not serving me right. If you use Cosmos DB and Fabric separately, then both have their own login ID. So it's a separate security model. But with Cosmos DB now available inside Microsoft Fabric, you don't even need an Azure ID. You just need Microsoft Fabric, and the security model has been unified.
It's integrated because we have a very streamlined RBAC approach in Fabric, and then the other things, as I said, right? Business model is also streamlined. It's like one capacity that basically covers
Yeah.
everything.
So
It
one
goes from
SKU, one pricing capacity unit for.
So it's all capacity units, and
Right.
different workloads can have different kinds of capacity measures based on the usage, but it is really just one capacity unit. So what ends up happening is that you basically provision capacity unit. You could insert the data into Cosmos. You could retrieve it to do some real-time eventing, messaging, or whatever along with it, and build your entire event-driven architecture, and then push it out, or Power BI can basically visualize it. Everything is happening with one unit, right? It's sort of like CPU is the only unit that you got. Different workloads will charge differently, but the point is, it's dipping into the same business model. And again, governance, security, data consistency in one place.
Yeah.
It's all taken care in Fabric, and that's the power of simplifying all these pieces. Instead of having to deal with n number of services, with n number of sort of seams that you need to manage. You don't have to manage all these seams because we are working hard to make all the data go through one lake, make all these connections simplified. Operational databases will still have their operational format, but
Correct.
it works well with the rest of one lake.
So you've collapsed all the packaging, pricing, identity and access management, governance, security model into Fabric. and now you get both the benefits of operational and the analytical
You
sides.
got it. That's exactly what's happening here. And we're going to do it with all the operation databases as well. So we've started with
Even more.
SQL. Now we brought in Cosmos. Cosmos is interesting because you now can do the pace at which it evolves in terms of, because given that schema free, it has its real time
Right.
characteristics. SQL is equally popular. We'd love to have
Mm,
power of relational databases together.
mm,
One of the coolest things that we've recently done, Sanjeev, is this thing called basically is the ability for BI reports
mm.
to edit the data in line. So it's not just simple just consume read only once you report it. Once you create the report, you could actually go and edit it, and it inline edits it. And because we have now the power of operational databases together in Fabric, we actually have the ability to inline edit your reports, and that can be surfaced uh, with strong consistency because it's all backed up in one place.
It used to be Power BI to get the speed. It used to make a copy of the data on the client side, but now in Power BI, you can go and write directly to
Make
modify
it
data.
code, exactly. Yeah. So all the complexity of managing these kinds of like forks or like, what happened to one copy to the other copy, etc., those problems are all disappearing because that is the power of unified data estate.
Yeah. How is Cosmos DB and other operation databases writing their data to eventually be in Iceberg or Delta table formats?
Yeah, so we basically, as you know, obviously we need row store because OLTP doesn't work without row store, right? It just
Yeah.
won't work. All of the asset characteristics, the latency, read-write performances, etc., are built on row store. So we're going to keep the row store intact. We're not changing that. But there is at the transaction boundary in a near real time, we keep basically moving the data into our one lake. And so that's kind of really the magic. And that's what we call as mirroring. And we manage our own mirroring across all the workloads. We do it for all kinds of sources. We have a data integration team. We work closely with all our different kinds of sources. And that is what we call as mirroring. So it basically consistently in near real time is getting replicated. The
Hmm.
log is basically being transformed into the columnar store. And we do it with all kinds of sources.
Very nice. There's so many different angles that we can discuss. So I'm going to ask just a few questions as we get closer to the end. Unstructured data. In operation databases, do you support data in PDFs, videos, images, text?
Yeah. Yeah, I mean, this is kind of really where that's the power of being a hyperscale vendor, and like, we sort of like really have a great kinds of opportunities and optionality here in
Hmm.
Azure. So we support semi-structured and structured data with all our operational databases, and we also support with AI search the unstructured data in terms of providing Gen AI capabilities. So we have that, and Fabric it's one lake, so you have all kinds of data with metadata tagged and with great capabilities of governance, catalog, and all that stuff. So one lake really gives you all that stuff. With databases coming into Fabric, you have the holistic answer effectively.
Got it. Okay, thank you. I'm going to ask, so moving away from technology, let's talk about deployments because hyperscalers have that advantage of extreme scale. Can you talk about what are some of the biggest deployments that you work with on operational side? Which industries, which clients, verticals, anything you can share?
Yeah, you see, this is again one of the coolest things of being at Microsoft for me is that you touch not just the mission critical highest end of enterprise workloads, but also some of the digital natives who are up and coming, who are growing
Hmm.
rapidly, and everything in between, including like all the way to the other end of the tail or hobbies, apps, etc. So some of the cool numbers that I could share with you is that 97% of Fortune 500 customers use Azure SQL. That's practically any important customer with any important
90% of Fortune
97,
100.
97% of Fortune 500
I
customers.
see.
They all use Azure SQLs. It's super ubiquitous. It's there everywhere.
Hmm.
On Postgres, and I'm very proud of the pace at which we've been growing, and we are number one in terms of our commits to the latest PG edition, the version that's coming out. On 17 and even 18, we are continuing that momentum. So it's very, very cool. And now, specifically on the workloads, one of the things that I'm very proud of is the scale at which first and foremost the internal apps use. before even we go to the external apps. Most every service inside Microsoft, Azure, even security, Office, Xbox, Bing, every one of them use operational databases at a significant scale. One of the coolest things that one example that I would point out here is Microsoft Teams, which is the fastest growing sort of consumer app that we have. It operates at a massive scale, and Microsoft Teams basically uses Cosmos DB for messaging, and it has trillions of queries basically coming in with sort of like petabyte scale of data. These numbers are mind blowing, and they continue to scale. When you go step out a little bit and look at the external customers, uh, the funnest one, the most exciting one at this point, of course, there's everybody is exciting and we really love all our
Mm,
customers. uh, OpenAI is a customer
mm,
of Microsoft, for instance, and that has been growing multiple orders of magnitude every few months. Right? And we support all of that on all of the user facing actions of OpenAI goes through Cosmos DB. So when you're doing your chat GPT messaging, when you are basically doing any of your user profile messaging, of course, that's huge, right? You're chatting, everything is basically
yeah.
being supported by Cosmos, and it has to be super highly available. It has to be super low latency. It cannot have like the resiliency characteristics and the security characteristics need to be super top of the class. And we're thrilled to support that workload, and it continues to grow. And it's just the very definition of linear scale, the very definition of elastic, superior, infinite scale is the OpenAI ChatGPT workload, and we're very proud to support that. In addition to that, we have some of the most mission critical workloads like Walmart's customer journey
Mm,
for e-commerce applications, BMW, UBS. There's just many. Of course, as I said, Fortune 500. Most of those customers use Azure SQL, including Postgres now. If you think about the Postgres applications, oh, by the way, OpenAI also uses Postgres. It uses Cosmos DB and our Postgres as well.
oh, oh, wow.
Yeah, so
What is
OpenAI
the
uses.
use case for Postgres?
So any of the sort of like customer engagements in terms of um, login, identity management, etc.,
Oh,
they are
wow.
all going through the Postgres, including recently when they did their the image generation with Ghibli, for example, all of the Sora video generation, etc. A lot of that metadata, user activity, etc., goes through Postgres, and we've innovated quite a bit along with the team at OpenAI. They are a fantastic team, and we collaborate with them. And we are scaling, we are innovating along with them. In addition to that, again, there's lots of great stories, great workloads that we have across the board. As I said, this is one of the coolest things of being at Microsoft, where you kind of touch
Yeah.
all the way from the mission critical to mid market simple apps as well. Yeah.
Amazing. Great. Well, thank you so much for sharing the amazing use cases. Enamored. Actually, just think about ChatGPT's use of Cosmos DB, how it never goes down, and the low latency response times are so good, is truly phenomenal. As OpenAI is growing so rapidly, so is this underlying database. There are even other databases that we don't have time to talk about, like ADE, where every error gets logged. Custo is a language, right? Can you take a second to just walk us
Yeah,
through?
100%. Along with the OLTP databases that I touched upon, we basically have very proud of our data warehouse efforts that we've been, pushing and investing in. So we are innovating quite a bit into Fabric data warehouse, which is really our classic flagship data warehouse. It has compared with T-SQL, so it's the same kind of grown from the SQL engine. So we have a really good story there. When you bring Fabric SQL database, SQL data warehouse, they share the same sort of T-SQL engagement and fidelity of data types, etc. In addition to that, we also have Custo, which is basically think of it as the real-time log analytics kind of a database, and it is the bedrock for everything that happens at Microsoft in terms of our observability stories. And there's just tons of really awesome case studies that I can refer to. But it is a bedrock for everything that happens in Microsoft's observability, and you can imagine the scale at which it has to operate to
Oh,
go
yeah.
do that.
Yeah.
AI search is the other one that I talked about.
Yeah.
It's more Elasticsearch compared, but it has evolved quite a bit to do quite a lot of AI workloads as well. MySQL, again, I touched upon it in the OLTP space. There's a lot that's going on here.
Yeah, absolutely. Okay, so we're gonna change tracks. Just we're gonna end on some personal stuff. So I'm curious. You boomerang back into Microsoft. What are some of the mistakes you've made and you've learned from? Can you share something for viewers that's inspiring and something we can learn from?
Yeah, I think um, one of the coolest things about our technology is that it gets disrupted quite often,
Hmm.
and not being open to sort of really learning and unlearning in some cases, etc., is a fatal flaw. Because often when you spend significant amount of time in a certain
Yeah,
industry in a certain space, you kind of get biased to certain ideas, and you think that that will work because you've seen it work multiple times, but things are changing. Even the simplest thing about scale out, for example, commodity servers, etc., scale out really worked well, but there's a new bottleneck in terms of interconnects between nodes, and how do you really tackle that? Not being open to that and really adjusting it, I guess, is the lesson there. I would also say, just from my own leadership experiences and just the journey, one of my biggest mistakes was trying to do too much and too fast, and you think that as a leader you got to have all the answers. um, it's just sort of not sustainable, and most importantly, it doesn't give space for people to grow. I think that's another like really important lesson. um, Maybe I would say the last lesson is that, like, I have definitely had my own share of shipping products that technically work, but sometimes they don't land well with the customers, and that kind of really teaches you how to think about the difference between the technical correctness and the product resonance. So those are a few of the sort of, like, professional learnings that I've had for sure over
yeah.
the course of time. Yeah.
And that's so, I mean, that just happened. In fact, just as we are recording this, this is past week was filled with Replit deleting a production database and Amazon Q having prompt injection attacks. And so it's like, it's just something that we as developers have to always stay on top of.
Lots
So,
happening, and there's definitely a lot of
yeah,
iterations that I'm pretty sure we all need to be glued to
yeah,
learn and
correct.
iterate.
Yeah.
Yes.
In fact, I think there are more people trying to secure AI than people who are actually developing on AI. So, which tells you something. So, so
Early days.
one last question.
Yes.
Last time when you were on this podcast, I asked you, do you have fun hobbies? And I was so surprised when you said, "Well, I collect cricket balls." I'm like, "Wait, cricket balls?" And then you walked to your home office and you showed us one
Yeah.
of those. Any new fun hobbies that you have since then added?
It's a great question, Sanjeev. So, firstly, my cricket ball collection is growing. I recently
Ah,
got my hands on an old Duke ball. Duke balls are basically the English balls, and they're different ones than the Kookaburras and SG. SG is what we use in the Indian subcontinent. Kookaburra is the Australian version. Duke is special. It's the oldest version. So I got a hands on the oldest one of the older ones.
oh wow.
Super excited about that. But lately, though, work keeps me busy. I don't think the spending too much energy on those. I think building AI apps is certainly in my docket. I between the kid chores, work schedules,
Yes,
it's been exciting
vibe
to.
coding.
Yeah, definitely. I've been tinkering with vibe coding and my own share of like personal productivity and home running and all that stuff. The other one is guzzles. Like, I've gone as a, I don't know, we haven't talked about it. This is one of those things where I evolved. I have never been like this, but I've evolved into sort of appreciating the guzzles, and I do think that it's not just about the melodies, but the silence between the lines and the pauses. It's very, very soothing, and I spend a lot of time, I guess, appreciating that part of the side whenever I'm not working.
I had
Um,
no idea
yeah,
you were a music aficionado. Do you sing
I'd
also?
say, yeah, I can't sing, but I listen. I take the easy part.
That is amazing. Great. Shirish, it's such a pleasure. I can't wait to do another one with some absolutely new mind-boggling additions. But I really want to thank you. I know you literally you told me how busy your day is, and with all that's going on, thank you for taking the time.
Oh, the pleasure is totally mine, Sanjeev. Thank you so very much for giving this opportunity. It's always exciting to talk to you, and I can't wait to talk to you again, catch up with you again soon.
Amazing. Thank you, viewers. Until next time, signing off. See you.